Hello students, welcome to my channel Sarika Krishna Online Classes. This side Sarika, your maths teacher. So now as we are already doing this introduction to trigonometry, this is the now third part of introduction to trigonometry. In this I'll explain trigonometric identities. There are certain trigonometric identities. There are three main identities. From those three we can derive three more, right? So total 9 identities are there. But how they are derived, how they are formed, right? So the derivation, how they are formed identities, right? Now we'll do that. Okay, now we know that this is a right triangle, right? So this is hypotenuse, the longest side is the hypotenuse, this is the base, and this, if we talk about theta, this is perpendicular, right? Now here hypotenuse square is equal to p square plus b square, that is Pythagoras theorem. Now here, if we divide this equation by h square, so h square by h square, right here, p square by h square, throughout we have to divide it by h square. What we are doing, we are dividing throughout this whole equation by hypotenuse square, right? This becomes here 1, p by h. This becomes, what is p by h? P by h whole square. We'll write it this way, that is p by h whole square, right? Now, we know that perpendicular upon hypotenuse is sine square theta. B by base upon hypotenuse is cos, since it is square outside, so cos square theta. So p by perpendicular upon hypotenuse is sine theta, base upon hypotenuse is cos theta. So we have converted this p by h and b by h to sine square cos square, right? There was square. So this is one identity, that sine square theta plus cos square theta is equal to 1. We have derived one identity, right? Identity having sine square and cos square, right? So I'll repeat this. How do we write the Pythagoras theorem? Hypotenuse square is equal to p square plus b square. Then divide throughout this equation by h square. Here it comes 1, here it becomes p by h, b by h, उनके squares हैं बाहर लिख लो. Then this perpendicular hypotenuse, that is sine. We know that trigonometric ratios, right? Sin theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse. So आप इसकी जगह cos लिख लो, उसकी जगह sin लिख लो, क्योंकि बाहर square था. So we are supposed to square that. So this is the first identity. Sin square theta plus cos square theta is equal to 1. In the question we don't have to prove, but we should know how it is derived. So this is first identity. From this identity we are going to derive other two, right? Now let us do here. Okay, now sin square theta plus cos square theta is equal to 1, right? So, okay children, so let us, okay. So now here, if we divide this equation, this identity by, throughout by cos theta, right? Let us do that. Cos theta, cos square theta, right? Here cos square theta and here cos square theta. So what is sine upon cos? That is tan theta. So it becomes tan square theta. This becomes here 1. 1 upon cos square is secant square theta. So one more identity, that is 1 plus tan square theta is equal to secant square theta. So this is the second identity. What we did, we got this first identity, we divided throughout by, right? We can do the same operations, right? Throughout the equation. Left side पे भी right side पे. जिससे आप divide left पे कर रहे हो, just divided by that right on the right side also. So here throughout means left side पे भी right side पे we are dividing by cos square theta. So each and every term when it is divided by cos square theta, so we are left with this. Sin by cos, ratio of sin theta and cos theta is tangent theta. I have already explained in my previous video. So this is tan square, cos square, that becomes 1, 1 upon cos. 1 upon cos, किसका? What is the reciprocal of cos? That is secant. So if it is square, it has to be square there. So second identity is 1 plus tan square is secant square. So first identity was sin square theta plus cos square theta is equal to 1. Second identity is 1 plus tan square theta is equal to secant square theta. Now the third identity can be derived. Now what we are going to do, we are going to divide this equation, this first identity by now sin square. अभी हमने cos square से divide किया, अब हम same identity, the first identity जो है उसको we'll be dividing by throughout by sin square theta. क्या किया? पहले cos square से divide किया, अब sin square से divide करेंगे. So let us see what are the changes here. This cancels, it becomes 1. Cos upon sin होता है cot, right? Sin, I'll write here. What is tan? That is sin theta upon cos theta का ratio होता है, right? If it is cot theta tan का reciprocal होता है. So it will be cos theta upon sin theta. उल्टा हो जाएगा इसका, right? So here cos theta upon sin theta था यहाँ, it becomes cot square. यहाँ 1 upon sin था, sin का reciprocal, right? That is cosecant square theta. What is cosecant reciprocal of sin? What is secant reciprocal of cos? So this is the third identity. So we have got three identities, right? Sin square theta plus cos square theta is equal to 1. Second, 1 plus tan square equal to secant square. Third, 1 plus cot square equals to cosecant square. So इससे हम two more derive कर सकते हैं. Let us do that. I'll rub this, right? Okay, now from the first identity, that is cos square theta, sin square theta plus cos square theta is equal to 1. We can derive the other identities. How? If we want to write sin square theta here, we can write 1 minus cos square theta. Cos उधर चला जाएगा. If we want to find out cos square theta, तब 1 sin goes that side. So we can use these identities also. ये इसी से ड्राइव हुई है. आपने sin निकालना है, cos को उधर ले जाओ. Cos निकालना है तो sin को उधर ले जाओ. Right? Then fourth, हमारी second identity क्या थी? This one. Tan square theta plus 1 is equal to secant square theta. राइट, ये वाली सेकेंड वाली आइडेंटिटी थी. इससे भी हम 2 मोर लिख सकते हैं. हाउ? अगर आपको सिर्फ tan स्क्वायर यू वांट टू फाइंड आउट, तो 1 गोज टू द राइट साइड विद अ चेंज ऑफ साइन. इसी में से अगर हम secant स्क्वायर थीटा हम tan को उधर ले जाएं तो हमारा लेफ्ट में 1 बच जाता है. ठीक है, tan secant स्क्वायर माइनस tan स्क्वायर वो 1 होगा. सो वी हैव डिराइव्ड 2 मोर आइडेंटिटीज फ्रॉम द सेकेंड आइडेंटिटी. नाउ व्हिच वाज द this third one? This was this one. 1 plus cot square theta is equal to cosecant square theta. ये हमारी थर्ड वाली थी. इससे भी हम डिराइव कर सकते हैं. 2 more we can derive. अगर हमें cot निकालना है, cot square theta will be cosecant square theta minus 1. वो माइनस उधर जाएगा. और अगर हमने इसी आइडेंटिटी में cosecant minus cot लिखना है, so cosecant square theta ये वाला, cot अगर उधर जाता है तो cot square theta that यहाँ पे 1 रह जाता है. Right? So what I did? First I derived the 3 main identities. उसमें से 2 और हम लिख सकते हैं उसी को modify करके. Right? I'm repeating this whole again. We have a right triangle. We have base. We have perpendicular. We have hypotenuse. Apply the Pythagoras theorem. Done. Throughout divide by h square hypotenuse. Done. यहाँ 1 आ गया आपका. ये कुछ रेशो आएगी. Trigonometric रेशो की टर्म्स में उसको लिख लो. ये साइन होता है, वो cos होता है. sin square cos square. So we have got one identity, that sin square theta plus cos square theta is equal to 1. इसी से हमने 2 और निकाल ली. क्या किया? इसी को एक बार cos स्क्वायर से डिवाइड कर लिया. इसी को हमने एक बार वी डिवाइडेड इट बाय sin स्क्वायर थीटा. चलो वो हमने यहाँ कर दिया. हमारी आइडेंटिटी थी sin स्क्वायर थीटा प्लस cos स्क्वायर थीटा इक्वल टू 1. थ्रू आउट डिवाइड बाय cos स्क्वायर cos स्क्वायर cos स्क्वायर. जो आंसर आते हैं sin अपॉन cos का रेशियो जो है वो tan होता है, या cos cos कट गया 1 होता है. 1 अपॉन cos secant स्क्वायर होता है. 1 अपॉन cos जो रेसिप्रोकल cos का दैट इज secant स्क्वायर. तो हमारे पास एक और आइडेंटिटी आ गई. सेम फर्स्ट वाली जो आइडेंटिटी थी, अगर इसको वी विल डिवाइड बाय साइन. साइन से हमने उसको डिवाइड कर दिया. sin स्क्वायर थीटा प्लस cos स्क्वायर थीटा इक्वल्स टू 1 को अगर आप sin स्क्वायर से डिवाइड करते हैं, व्हाट आर द चेंजेस? हियर इट बिकम्स 1, हियर इट बिकम्स cos अपॉन sin. रेशियो ऑफ sin अपॉन cos इज tan. अगर उल्टा रेशियो आ जाए cos अपॉन sin तो cot होता है. So ये this becomes cot square and 1 upon sin. Sin का reciprocal cosecant square होता है. So we have got the third one. So 1, 2 and 3. 3 main identities में से this was the one, right? This one first one, this was the second one, and this the third one. Now we can derive from this was the main one, right? This was the main identity and this was the main identity. इससे हमने derive कर दिए 2 more, right? कैसे? What we did? अगर sin स्क्वायर आपको sin स्क्वायर की वैल्यू यू हैव टू सब्स्टिट्यूट इन द क्वेश्चन, तो आप ये डाल सकते हैं 1 माइनस cos स्क्वायर. अगर यहाँ पर यू वांट टू सब्स्टिट्यूट द वैल्यू ऑफ cos स्क्वायर तो आप लिख लो 1 माइनस sin स्क्वायर, उधर चला जाएगा. सो 2 इससे और डिराइव होगी, राइट? सो दिस नेक्स्ट वन वाज tan स्क्वायर प्लस tan स्क्वायर थीटा प्लस 1 इक्वल्स टू secant स्क्वायर थीटा. इसमें से भी आप डिराइव कर सकते हो. इफ यू वांट टू सब्स्टिट्यूट द वैल्यू ऑफ tan स्क्वायर इन सम क्वेश्चन, वो क्या होगा? यहीं से देख लो, secant स्क्वायर माइनस 1. और अगर आपको 1 चाहिए, आप secant स्क्वायर माइनस tan को उधर ले जाओ. secant स्क्वायर थीटा माइनस tan स्क्वायर थीटा आपका 1 होगा. तो दिस इज दैट वन. सिमिलरली द लास्ट वन 1 प्लस cot स्क्वायर cosecant स्क्वायर. आपको cot स्क्वायर की वैल्यू चाहिए तो cosecant स्क्वायर माइनस 1, और अगर आपको cosecant स्क्वायर माइनस cot स्क्वायर माइनस में चाहिए तो आंसर 1 होगा. सो दीज आर द आइडेंटिटीज. नाउ हाउ दे हैव बीन डिराइव्ड. So I have explained, you don't have to derive in the question, you have to directly use, but you should know the basics. Now we'll do the questions, we'll prove the identities, prove that LHS equals to RHS, right? Okay, let us do the questions, children. Okay, students. Now we will do some questions in which the identities are required, right? These are some. I'll be doing some questions from NCERT book, right? So the question is cosecant theta minus cot theta whole square is equal to 1 minus cos theta upon 1 plus cos theta. So this is the left hand side. I'll modify from the left hand side. I'll start from left hand side and I'll prove same as RHS, right hand side. So you can modify both the sides also. LHS also you can modify the RHS also. आप left hand side में भी कुछ solve कर सकते हैं, right में भी कुछ solve कर सकते हैं, but in the end you should be able to prove that LHS equals to RHS, right? So now here, when there are like these trigonometric functions are there, cosecant, secant, cot and tan, we should try to convert them into sine and cos, right? So right side it is already in terms of cos. Here let us change this secant, cosecant, right? So here cosecant, that is 1 upon sine, that is the reciprocal of sine. Here cot is written as cos theta upon sine theta, right? Whole square outside. 1 upon sine theta is cos cosecant theta and cot is cos upon sine. If there is tan, that is sine theta upon cos theta. Agar cot hai to cos theta upon sine theta, right? Now here we can take the LCM, that is same sine theta, right? Whole square will be outside here. So it remains the same here, 1 minus cos theta. Okay, so here denominator is same, this is same and whole square. So here we can write it this way, 1 minus cos theta whole square and here sine square theta. I have separated the square. इस ब्रैकेट को भी मैंने स्क्वायर लगा दिया, साइन के ऊपर भी स्क्वायर लगा दिया. I've separated the squares. Now I'll be using the identity here. अभी तक तो सिंप्लीफिकेशन चल रहा था, एलसीएम लिया, राइट? नाउ हियर आई एम गोइंग टू यूज द आइडेंटिटी हियर, 1 minus cos theta whole square. You have to see what you have to prove in the right side. Right side mein there is 1 minus cos, so I will not modify this. I already have the numerator there. I have to change this into the denominator. So what was that identity? First you need to write the identity which you are using. Sin square theta plus cos square theta is equal to 1. So sin square theta is equal to 1 minus cos square theta, right? So just in place of this I am writing 1 minus cos square theta, right? But it is square, it is not square. So what I'll be doing here, now from here I'm writing here. So 1 minus cos theta, we will not modify this. This is a square minus b square. 1 square means same. A square minus b square, write out the formula there. A square minus b square, that is equals to a plus b in one bracket, a minus b in the other bracket. So what is a square minus b square? That is a plus b into a minus b. So we are converting it into two brackets here. A is 1 plus cos theta and 1 minus cos theta. अब हम स्क्वायर्स नहीं पुट करेंगे क्योंकि स्क्वायर का फॉर्मूला था वो, ए स्क्वायर माइनस बी स्क्वायर. सो आउट ऑफ दीज टू इसके पास दो ब्रैकेट्स हैं यहाँ, वो स्क्वायर कट जाएगा, एक ब्रैकेट कैंसिल हो जाएगी, राइट? ऊपर दो ब्रैकेट्स थी बिकॉज इट वाज होल स्क्वायर. सो वन ब्रैकेट हियर, दिस इज लेफ्ट हियर वन फैक्टर एंड हियर पॉजिटिव फैक्टर इज लेफ्ट इन द डिनोमिनेटर. न्यूमरेटर में 1 माइनस कॉस थीटा होल स्क्वायर था, सो दैट मीन्स 1 माइनस कॉस थीटा इंटू 1 माइनस कॉस थीटा दो बार. सो एक बार आप कैंसिल विद दिस, वो स्क्वायर नहीं रहेगा, एक फैक्टर कट गया, एक बच गया, 1, we are left with 1 and here the positive factor is left, right? Now see, now check, that is same as RHS, right? So I started from LHS and I completed same as RHS. I'll repeat this again. What happens when you have an identity? Whenever you have tangent theta, cot theta, cosecant theta and secant theta, just change these four trigonometric functions into cos theta and sin theta, right? So first tangent theta. What is tan theta? In terms of sin and cos, it is sin theta upon cos theta. What is cot theta? It is cos theta upon sin theta. What is secant theta? It is 1 upon cos theta. What is cosecant theta? It is 1 upon sin theta. तो ये आपको पता होना चाहिए कौन सा किसका रेसिप्रोकल है और टेंजेंट किसके रेशियो के इक्वल है, साइन और कॉस के, राइट? ओके, नाउ हियर it is cosecant is 1 upon sine, cot is cos upon sine. स्क्वायर हमने बाहर रख दिया, यहाँ पर I took the LCM, right? स्क्वायर सेपरेट कर लिए, इसमें आइडेंटिटी लगा दी. दिस इज द आइडेंटिटी हियर. हाउ टू यूज द आइडेंटिटी? यू हैव टू सी RHS. RHS में आपको जो चाहिए आपको वो लेके आना. नाउ this here it is 1 plus cos theta, so it means you have to change sin into 1 in terms of cos. तो हमने कर दिया अकॉर्डिंग टू फॉर्मूला. सो साइन स्क्वायर थीटा इज 1 माइनस कॉस स्क्वायर. अब ये तो कॉस स्क्वायर है, वी डोंट वांट स्क्वायर, जस्ट अप्लाई द फॉर्मूला हियर. ए स्क्वायर माइनस बी स्क्वायर, तो दो फैक्टर्स आ गए ए प्लस बी ए माइनस बी। ऊपर वाले के पास दो ब्रैकेट्स है क्योंकि स्क्वायर लगा हुआ है, वन ब्रैकेट वी हैव कैंसल्ड एंड वी आर लेफ्ट विद 1 माइनस cos थीटा अपॉन 1 plus cos थीटा, दैट इज सेम एज RHS, right? So now we'll be doing the next question, other question of NCERT only. Okay, students, let us do the next question. Right now we have to prove that cos A upon 1 plus cos A plus 1 plus sin A upon cos A is equal to 2 secant A. So what we have this on the left hand side. It seems to be very complicated, but it is not. We have a fraction. We'll be taking the LCM. Left hand side, right? So left hand side is cos A. Left hand side we have to write again, right? So sin A upon cos of A, right? So here we'll take the LCM. As these terms, they are already, these trigonometric functions, they are already in the form of cos theta and sin theta, or cos A or sin A. So we don't have to change because इसमें tangent नहीं है, cot नहीं है, cosecant नहीं है, secant नहीं. So LCM, we'll be taking the LCM. एक factor ये आपके पास है, एक factor ये आपके पास है. So this will be the LCM. एक ये भी होगा और ये भी होगा. Now इसके पास ये factor है. So ये cos इधर multiply होता है cos के साथ, cos square हो जाएगा. Right? इसके पास जो फैक्टर होता है, it already have this factor, it doesn't have this, so you are supposed to multiply the numerator by this. So cos square into cos square, cos square. यहाँ पे cos है, you are supposed to multiply numerator by this bracket. तो आपके पास bracket दो हो जाएंगी ऊपर, so that will be square, right? एक ये bracket है, इसको आपने किससे into करना है? इस bracket से. क्यों? Because denominator में cos है, ये नहीं है, तो you are supposed to multiply, right? Now apply the formula of a plus b whole square. Cos square A plus A square means 1 square is 1, B square plus twice AB. The formula which you are using, you have to write in the bracket, right? So आपने क्या formula use किया है, आप उसको वहाँ पे सामने यहीं पे लिख दो, that A plus B whole square is equal to A square and right, okay, A square B square plus 2AB, और A square plus 2AB plus B square आगे पीछे आप लिख सकते हो, no problem in that. Now here एक आइडेंटिटी है, इन दो को मिला के बनती है, sin square plus cos square, that is 1. I'm using that identity here, so I'll be writing also 1 plus sin A. What I did, cos square plus sin square 1 है, तो you have to write in the bracket because sin square A plus cos square A, that is 1. So हमने इन दोनों को 1 बना दिया, एक ऑलरेडी 1 वहाँ था, 2 sin A था, and this was the question, right? So I hope it is clear. First of all, I have taken the LCM. LCM में आपके पास जो जो factors हैं, you have to take them. इसके पास ये factor नहीं है तो ये multiply करना, इसके पास ये factor नहीं है तो you are supposed to multiply by this. After that, bracket, open the bracket A plus B whole square. The formula which you are using, you have to write that formula here in the bracket A plus B whole square is equal to A square plus B square plus 2AB. Then after doing that, A square plus B square plus 2AB, then you have to apply the identity, right? So we can see that here, sin square plus cos square, it is 1 and this becomes 1, already there is 1. So 1 plus 1 is 2. I'll do here now. Right, 1 plus 1 is 2 plus 2 sin A upon cos of A and 1 plus sin of A, right? So I'll drop this here. Okay. Now, okay, now here it becomes, right, you can see 2 is common there, 1 plus sin A, we are left with this inside here, cos of A and 1 plus sin A, same in the denominator. So this whole bracket we are able to cancel and we are left with 2 upon cos A. So 2 into 1 upon cos, 1 upon 1 cos is secant, 2 secant A, and that we have got the answer RHS, right hand side, right? So step by step we have to see what we can do. First there was a fraction, we took the LCM, then a formula has to be applied there, A plus B whole square. Then I saw that I can make the identity, make that. Then what changes have to be done? 2. अब यहाँ पे you'll see that अभी तो नहीं बन रहा कुछ secant. Then we'll be taking 2 common. Common लेने के बाद we are able to cancel the bracket and we are left with 2 upon cos A. So 1 upon cos secant होता है. We got the result. So this is a question how step by step we have proved that LHS is equal to RHS in the last, right? Hence proved. LHS equals to RHS. Now we'll do the next question. Okay students, now we will do this question. Whenever there is something inside the root whether it's sine or cos, you should rationalize it, right? So what is rationalizing? First we'll write the question. LHS equals to, inside the root we have 1 plus sine A upon 1 minus sine A. Rationalizing means, right here, rationalizing the denominator, right? So what is rationalizing? You just have to multiply and divide by the denominator, but with the change of sign. आपको साइन चेंज करना होता है डिनोमिनेटर का, और उसी से जो डिनोमिनेटर में डिवाइड एंड मल्टीप्लाई करते हैं, बट चेंज द साइन. इफ दैट इज नेगेटिव पुट पॉजिटिव, इफ दैट इज पॉजिटिव पुट नेगेटिव, राइट? So now here we have same into brackets, so it's 1 plus sine A whole square, and here it's 1 minus sine into 1 plus sine A square minus B square, 1 minus sine square A, right? The formulas which we are using you can write in the bracket, right? So I'll be writing here, first I used 1 A plus B into A minus A plus B into A minus B is equal to A square minus B square, right? In the denominator A plus B, A minus B, A square minus B square, 1 ka square is 1 only, right? So it becomes here 1 plus sine A whole square upon 1 minus sine square is cos square A, right? Since both are in square, right? So common आप लिख लो. You can write whole square outside both numerator and denominator, a common square there, right? Or root or square cancel हो जाते हैं, so we are left with this part only. Now we have to see what we have to prove. There are separate terms. Separate the denominators. 1 upon cos A plus sin A upon cos A. हमने क्या किया? We have separated the denominator. 1 upon cos, sin upon cos. We know that 1 upon cos is secant. Reciprocal of cos is secant A. And what is the ratio of sin theta and cos theta? Sin A and cos A, that is tan A. So let us see the result. Yes, we have proved that. So RHS. So we started from LHS. So whenever the question is something is inside the root, do rationalizing the denominator, right? Rationalizing means whatever you have in the denominator, उसको same उससे divide और multiply करो, but with the change of sign. अगर minus है तो plus लगाओ, plus है तो minus लगाओ. Change the sign, but जो denominator है उस same से just multiply and divide. After doing that, 1 plus sin A, 1 plus sin A means 1 plus sin A whole square. Here it is A plus B into A minus B. A plus B, A minus B. That is A square minus B square. 1 minus sin square, that is identity, and we have not written there because 1 minus sin square theta is equal to cos square theta. Right? Starting में हमने आइडेंटिटी निकाली थी. cos square अगर लिखना तो 1 minus sin square. वैसे तो आइडेंटिटी होती है ये वाली sin square theta plus cos square theta is equal to 1. So we have used this identity. So you should mention in the bracket whatever you are using. So इसका हमने ये बनाया, right? Identity से. Okay. Then after that, एक दो इसके ऊपर भी square है, इसके ऊपर square है. We just I just wrote the square outside. So square and under root we are able to cancel and we are left with this. After that, just separate the denominators. 1 upon cos is secant and sin upon cos is tan, and we have got the result. So step by step we have proved that LHS equals to RHS and hence proved. Okay, students, now we'll do the next question. Okay, now let us do this question, students. Now the question is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tangent theta. You have to prove this. Since it is already in sin and cos, so we don't have to change in sin and cos. So what we can do, we can take common sin theta from the numerator. देखो दो साइन दोनों के पास है. Here it is 1, it will be 1 here, and here it will be sin square theta. In the denominator we can see we can take out common cos theta, so we will be left with cos square theta minus 1. इतना हो गया. Now let us see the result, tangent theta, right? So ये जो sin theta cos theta का ratio है, already there is tangent theta, right? So we are left with this part. 2 cos square theta minus 1. So here we don't want this part here. It means we should be able to cancel this. सिर्फ आंसर आपका tangent theta. So I'll be changing 1. I'll be applying the identity either here or here. कहीं पे भी आप लगा लो, लेकिन just apply identity either in sin and cos, right? चलो sin में लगा लेते हैं here. 1 minus, right? 2. अब sin square है, According to identity, sin square is 1 minus cos square theta. So identity मैंने यहाँ लगा ली. If you have changed in the numerator, then don't change in the denominator, right? So क्योंकि वो दोबारा question बन जाएगा. अब जो identity आपने use किया, just write there sin square theta plus cos square theta is equal to 1. So मैंने क्या किया, sin square की value डाली 1 minus cos square from this identity. So this is the main one, right? So here tangent theta remains as it is. Here let us open this bracket here. 1 minus 2 ones are 2, minus minus is plus 2 cos square theta. इस bracket को minus 2 से multiply किया. So here in the denominator we'll keep the same here. So now tangent theta here, this becomes, पहले मैं ये लिख रही हूँ 2 cos square theta, right? Minus 2 plus 1 is minus 1. Here in the denominator is this. That's why I wrote 2 cos square theta first, then I wrote minus 1 because so that it becomes the same. So we are able to cancel this bracket and we have left with only tangent theta, and that is the required RHS. Right? I hope students it's equal. It's simple. So first you have to see the question. Just see the question. Think, analyze what changes you can do. Right? If it is trigonometric functions are these ones, tangent, cot, cosecant and secant. The first step is change it to sine and cos. But already if it is sine and cos, then think what can be done. Here sin cos कॉमन ले सकते थे. कॉमन लिया तो आपका ये tangent बन गया, आपका tangent रिजल्ट आ गया. अब इसका क्या करना, कैसे कैंसिल होगा ये? चलो ये करते हैं, या तो आइडेंटिटी यहाँ लगा लेते हैं या यहाँ लगा लेते हैं, किसी एक पे आइडेंटिटी आप लगा लो. सो व्हाट आई यूज आइडेंटिटी इन साइन स्क्वायर, तो मेरा कॉस स्क्वायर में चेंज हो गया तो मैंने आई जस्ट ओपन द ब्रैकेट, देखा क्या रिजल्ट बचा, वो सेम बचा जो नीचे था. सो सेम ब्रैकेट्स, राइट, वी कैन कैंसिल आउट एंड लेफ्ट विद tangent theta, which was the right hand side. So now let us do the next one. Okay students, now we will do this question here. Sin a plus cosecant a whole square plus cos a plus secant a whole square is equal to 7 plus tan square a plus cot square a. So let us start with LHS. What is in left hand side? We have to write that sin a plus cosecant a whole square plus cos a plus secant a whole square, right? Now apply the formula of a plus b whole square, right? So it becomes sin square a plus cosecant square a plus twice 2a into b, right? 2ab cosecant a. Similarly in this bracket, a plus b whole square is a square b square and twice ab, 2 into cos of a into secant of a, right? So then here we will combine this here, sin square a plus cos square a, we write them together here. So here this part here, 2 sin a, cosecant is 1 upon sin a, reciprocal of sin, just do this, those changes. I'm taking this part first here, 2 cos of a into 1 upon cos of a, I'm changing the secant into cos, plus this here cosecant square a plus secant square a, this is left here. Now let us see the changes here. Here I am using identity 1 because sin square a plus cos square is 1, plus this we can cancel, we are left with 2, ये वाला 2. अब cosecant square, I am using the identity here 1 plus cot square a, I am using the identity here 1 plus tan square a, right? So whatever you are using, you have to write here. First I use this identity here, sin square a plus cos square a, that is equal to 1. Then I use the identity 1 plus cot square a is equal to cosecant square a. Then I use the identity 1 plus tan square a is equal to secant square a, right? So now here 2, 3, 4, 5, 6, 7, we have got the result. First let me write tan square a, then cot square a is equal to RHS. So I hope it's clear, right? Now here first I opened the bracket a square b square 2ab, a square b square 2ab. Then I saw the changes, sin square cos square I wrote here, so that because it becomes the identity, right? 2 sin a cosecant a, cosecant is 1 upon sin, sin cancel, यहाँ पे 2 बचता है. Same here, ये वाला पहले ले लिया, cos secant a is 1 upon cos a, cos cancel हो गया, 2 आपके पास आ गया. Now we are left with एक ये रह गया था और एक ये, right? उसको आप बाद में लिख लो, ये दोनों. Now applying the identity here also, 1 plus cot square a, और secant होता है secant square is 1 plus tan square a, right? So ये दोनों आइडेंटिटीज किसके जगह लगी? कोसिकेंट स्क्वायर 1 plus cot square, secant square 1 plus tan square. वहां से और आगे नंबर्स 1 2 दिस टोटल 7 हो गया और cot square tan square and that was the required RHS 7 plus tan square plus cot square, right? So this is RHS and hence proved, right? It was very simple. We just applied the formula of a plus b. जो आपने formula use किया, write that also, right? Somewhere a plus b whole square is equal to a square plus b square plus 2ab. जो आपने use किया है, you have to write in the bracket whether it's a formula, whether it's an identity, right? Okay, now let us do the next question. Okay, now I'll be doing the last question, right, of this identity here. Now the question is this, so let us write the left hand side here, that is 1 plus secant A upon secant A. So here, let us change the secant A into cos, right? What is secant? 1 upon cos. So 1 plus 1 upon cos of A upon 1 upon cos A, right? I've changed the secant and cos of 1 upon this secant and this secant I have changed into 1 upon cos and 1 upon cos, right? So if taking LCM in the numerator, ये cos LCM लेंगे तो ये यहाँ multiply होगा cos of a plus 1, denominator में है 1 upon cos of a. So denominators cancel हो जाएंगे because दोनों के जब आप ऊपर करोगे reciprocal, so you are left with cos a plus 1 or 1 plus cos a, right? Same thing. Okay, now in this question I am going to modify RHS also, right? So sine square A RHS is this, right? So here I am using the identity of sine square. Sine square A plus cos square A is equal to 1. So sine square we write as 1 minus cos square A. You need to mention this because, right? So what is sine square? That is 1 minus cos square A upon 1 minus cos A. Denominator remains the same. So in the numerator, we have to apply a formula a square minus b square. 1 square is 1 only. So I am applying a square minus b square is equal to a plus b in one bracket into a minus b in another bracket. So here, so a plus b means 1 plus cos of a into 1 minus cos of a, because a is 1 and b is cos a. In the denominator, we have 1 minus cos a, right? So here, then what do we get? Yeah, can cancel this bracket 1 plus cos of a. What was the result here on the left hand side? It was 1 plus cos a. Right side also I have modified into 1 plus cos a. So you'll write LHS is equal to RHS. Hence proved, right? So sometimes in some questions you need to modify the RHS also. आप right hand side को भी changes, right hand side में भी changes कर सकते हो unless you are not able to prove, right? अगर आपसे prove नहीं हो रहा है तो just modify RHS also, LHS also, जितना हो सकता है उसको simplified form में ले आओ. It was not in simplified form. यहाँ identity लगाई मैंने 1 minus cos square, फिर formula लगाया a square minus b square, a minus b a plus b. So little आपको आइडिया हो गया, राइट? सो यू हैव टू सी LHS एंड RHS कि उसमें क्या प्रूफ करना है. तो जब आप प्रूफ कर रहे हैं साइड बाय साइड, जस्ट लुक एट द RHS. इफ यू आर डूइंग चेंजेस इन LHS, जस्ट साइड बाय साइड लुक एट RHS कि क्या चाहिए आपको रिजल्ट और वो कैसे आ सकता है. इफ यू आर मॉडिफाइंग द RHS, देन सी LHS. LHS में what is the result after modification, right? Okay, so I'm done with this topic here. Trigonometric identities and how to do the questions of trigonometric identities. Okay, thank you children. Stay blessed and do like, share my videos, like, and subscribe my channel if you have not subscribed. Thank you. Have a nice day.